Okay, so today I'm going to go through the first part of the second report uh, with an example, step by step. Our aim is to have a compiler which can compute the values of arithmetic expressions, including variables, and assign values to variables. So actually, just follow me. I will do it step by step, but it is just mainly a series of formulas. So compiler able to compute values of arithmetic expressions, including addition, subtraction, multiplication, division, and braces. Okay, and numbers and variables, and assign values to variables, and okay, compute and print values. Let's see an example. It looks like a equal to 2 plus 3, print a minus 1. Okay. Let's see the grammar rules. It is like S2 variable equal to expression, S2 print expression, and S2 S:\. Okay, so we can have practically these, okay, let's it be like V as a variable. For simplicity, V can be A or B or C or D. Okay. These can be the names of the variables, and expression can be either a term, expression can be E plus T, or can be E minus T, and similarly a term can be a factor, term can be t multiplied by f, or t can be t divided by f. Okay, f can be either a number or f can be a variable, or f can be an expression in braces. Okay. And okay, f is just a number. Okay, to have a predictive parser, we have to eliminate left recursion. Where we have left recursive expression, we have one here. Okay, so we have to identify the part which is okay, we have to all the rules for this. So we have to have the expressions which does not start with s, and then the remaining part which start with s. So in this case we have these two rules, and it is followed by s prime, both of them. And s prime can be either the empty string, or it can be the part which can be repeated in a way that it is repeated on the right hand side. So it is like column s and s prime. So this is the repeated part, and these are the expressions with no recursion. So we have the s prime for all the terms where we have no recursion, and for the s prime we have either empty or the repeated part. Okay, let's see the next one, where we have this e to t, e plus t, and e minus t. This is substituted by, so this is the only rule where we do not have any recursion, which means that we have the same symbol in the right hand side but we have on the left hand side, and we add E prime to the right. The E prime can be empty if we does not any repeated parts, or the E prime can be the repeated part, which is in this case plus T. Sorry, this is the other one. So we have plus T E prime and minus T E prime. Okay, and this is the only part which is not repeated, this T, which is written down here. Okay, let's see the next one. Actually, it is pretty similar. We have T to F. This is not repeated, and what is repeated is multiplied by F or divided by F. And this is substituted by the grammar rules. T2 F T prime, and then we have T prime to the empty string, and T prime to multiplication F T prime, and division F T prime. Okay, so this is what we have here. This is the repeated part noted by red. Okay, so you can find this method written down in the part titled elimination of left recursion. Okay, what else we have? If it is okay, I think it is over. So finally, we have a rules, a set of grammar rules. Which includes this part, then this one, and then this one, and what is not modified, we have just to copy. Okay, and what else we have? This one. Okay, so this is a set of grammar rules finally we have. And then we are going to set up this kind of parsing table like this. And to prepare such a parsing table, we have to identify first sets and follow sets. First is to identify which symbols leads to the application of certain grammar rule. And the follow sets is required when we have a rule like non-terminal to E. And in this case, E is the empty string. So what we can see in the input, it is not a symbol derived by this grammar rule because this one does not lead to any terminal symbols. But instead, what we can see in the input is something which is followed by this, which follows this E prime, for example. Okay, let's see how to compute these first sets. Okay, let's do it bottom up. Okay, let me extend it is to have exact rules for each. Okay, when we have first A, certainly it is equal to A because it always tries with an A, and similarly for all the others. So for the B, we have B. For the C, we have C. And for the D, we have D. It's easy. Okay, then go upward. For the grammar rule, F2E, then first E in braces always starts with an opening bracket, so it includes this one. For the V, we have the union of all grammar rules, so as a consequence of the first 6 statements, first V equals to A, B, C, and D as a consequence of the previous 4 steps. Okay. Okay, let's see for the F. First, V equals to this one, and then the next grammar rule is F to a number. Okay, and the first number, actually it can be any digit, so it is always starts with 1, 2, 3, and so on. Or maybe start with 0 to 9. Okay. And then if we have a grammar rule with E, it means E is an element of first T prime. It does not mean that starts with an empty string because it's hard to interpret. Instead, it means that we can eliminate this symbol by the application of the grammar rule E prime to T prime to E. So what we know is that E is an element of first T prime. And so first E equals to the set containing E. E in this case is the empty string. First multiplication ft prime is equal to the set containing the multiplication sign. And similarly, for the first division, ft prime always starts with a division sign. Okay, what else we have here? Okay, let's see. We have the grammar rule T to ft prime. First, ft prime equals to first f and what is first f? As a consequence of these rules, first f equals to the union of double sets, so it can be either a letter to E to D, or a number 0 to 9, or it can be an opening bracket. Okay, and in this case, if t starts with ft prime, then first ft prime equals to first f equals 2. So similarly, t can be started by either a letter, a number, or an opening bracket. Okay, then go further with the grammar rules. We have the grammar rules for E. Okay, so for the E prime, first E prime, the empty equals to the set containing the empty. The first plus the E prime equals to the set containing the plus. The minus t E prime contains minus, and first t E prime actually starts with the same as the beginning of first character of t, which equals to so as a result, first t equals to what we have here. Okay, and it is the same that we have here. So the expression itself can start with, start with a letter, a number, or an opening bracket. Okay, and the only symbol left is the S prime. Okay, let's see the S prime first. So first E equals to the set containing E. First semicolon S prime is always the semicolon. Okay, made a mistake at the example because the line should be separated by semicolon, so like this. Okay. And as a result, first S prime contains both the E and semicolon. In the case of S to E S prime, first V equals to S to E S prime is equals to first V, which equals to A to D, and first print ES prime is nothing but the print. Okay. Then we can start constructing the symbol table. So as you can see here, we have the non-terminals in the rows and the terminals in the columns. So we have S prime and E prime, T prime, F, V. Okay, so for the S, we have, okay, let's see all the symbols here. we have numbers 0 to 9. We have the variable names A to D. We have opening and closing bracket. We have plus. Oops, sorry. We have plus. We have minus, multiplication, division, and the dollar sign, which means the end of the input, and we have print. I think that's all. Okay, let's see what we have for the S. For A to D, we have this grammar rule. So if we have the initial symbol and the variable, then we have to apply this rule based on the first set. Okay, let's see. Okay, and the other in the first set is the print. So for the print, we have this grammar rule. So if we start with print, we have to apply the grammar rule print ES prime. Okay, let's see the S prime. S prime, when we have the semicolon, then we apply this grammar rule. Oh, so we have somewhere a semicolon. For the E rule, we have to have the follow set, so we are going to compute it later on. Okay, let's go further. For the E, for all these symbols, A to D, 0 to 9, and operating bracket, we have this A to T E prime, A to 3 prime for the digits, letters, and the opening bracket. Okay. We have no other rule here. For the E prime, if we have a plus or minus, it is easy. For the plus, we have plus TE prime. For the minus, we have minus TE prime. Okay. And again, for the empty, we have to compute the follow sets first. It will be the next step, but I'm going to set up the parsing table what we have. First step can be A to D 0 to 9 an opening bracket, and in this case it is applied for the T. So in the case of T, we have FT prime for these three cases. Okay, and then for the T prime, we have multiplication and division, and if we have at the input, we apply these rules. And for the empty, we have to compute the follow sets again. Let's see the F. If we have a variable, then it can be A to D. So in this case, we apply the grammar rule F to V. If we have a number, we apply the grammar rule F to number. And if we have an opening bracket, then we apply the grammar rule F to E in braces, brackets, F to, yeah. Here it is. Okay. And what else we have? We have V2 ABCD. Okay, it is either a B, a C, or a D. Okay, it is fine. So the only thing remaining is to compute these follow sets. So at this point, we have this parsing table, which looks like this one. Okay, where can I? Just have. Okay, grid is here. I was looking for the grid. Okay, so we have this, and I'm going to insert it as a picture. Okay, so the next step is compute the follow sets. And in this case, if we have, let's see, we have 3 rules. Place the $sign in the follow set of the initial symbol. So as a consequence, the $sign is an element of follow S. Okay, the next rule is if we have a production where a non-terminal is followed by an expression, then the first of the remaining part after the non-terminal, except the E, is placed in follow B. Okay, let's see such rules. So go through all the rules here. Okay, let's see this one. So there we have a non-terminal followed by something else. I eliminate those where we do not have any non-terminal like this. Okay, these are the rules. So for example, here we have E in the middle. As a result, first S prime minus the empty is an element of follow E, because S prime is follows E. Okay, let's see symbol subset. Okay. Okay, that's it. Follow. Okay, here we have a closing bracket right after the E, and that's why we have first this part, minus E element follow E, which means that the closing bracket is an element of the follow E. Okay, what else we have here? First S prime minus E element follow S. Okay, what is the first S prime? First S prime. There we have the S. It is somewhere here. S prime. First S prime includes. Okay, it includes the semicolon. So the semicolon is an element of follow S. Okay. Here we have an E prime following the T. So as a consequence, follow the first E prime minus E is an element of follow T. Okay, let's see. First E prime contains plus, minus, and E. Plus, minus, and E. So if we eliminate E, we have plus and minus. So as a result, plus and minus is in the follow set. Follow T. So T can be followed by a plus sign or a minus sign. Okay, let's see this one. It is pretty similar because T is followed by E prime, so it is the same. In this case, first T prime can be followed by, may follow the F. Okay, what is first T prime? Let's see. Here we have T prime, so as a result, first T prime contains multiplication, division, and the empty. So if we eliminate the empty, we have multiplication and division. So multiplication and division is included in follow F. Okay, it is similar here. And here we have first closing bracket is an element of follow E. So the closing bracket is an element of follow E. Okay. And what else we have? We have another rule that if we have a non-terminal at the end, or followed by something which can be eliminated because E is in its first set, then the first set of one is included in the first set of the other. So let's see the grammar rules again to find for which it is applicable. Okay, so where we have non-terminals at the end, we have all here, 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 yeah, here, not this one and one of these. Okay, so because E prime is at the end of the right hand side for the gamma rule with S, then follow A is equal to follow B, so follow S is a subset of follow S prime. So subset, and similarly since the empty is an element of first S prime, that's why we can eliminate the prime from here, and then follow F S will be a subset of follow E as well. Okay, the same thing here, and the same thing okay, we have this one here, which is actually as the same as what we already have, and then follow S prime becomes a subset of follow S. Okay, let's see, TE prime follow E is a subset of follow E prime, and since first E prime equals the empty, follow E is a subset of follow T as well. Okay, the same for these, and here we have follow T as a subset of follow T prime, and since empty is an element of first 3 prime, follow T is a subset of follow F as well. The same for these two, and because of this one, follow F is a subset of follow V. Follow V. Okay. So it is complete. What we have to do is just summarize. Let's see. Okay. Let's see. So we have a dollar sign, which is an element of follow S. So dollar sign is an element of follow S, sorry. Okay, let's see a connector. Okay, and then which one is the next one? First, S prime minus E is an element of follow E, which means that what is the first S prime? S prime is, okay, it contains only the column. So the column, semicolon, is an element of follow E. Okay, so we have semicolon, which is an element of follow E. Okay, so we have this one, and this one. Closing bracket is an element of follow A. Let's see. Closing bracket. Follow E. Okay, go further. Semicolon is an element of follow S. first S prime. Okay. Then plus minus is an element of follow T. So plus and minus follow T, and then plus and minus follow T. Okay, we have it. Multiplication is the division in follow F. Let's see. Multiplication division in follow F. Okay. And the closing bracket in follow E. You already have it. Then follow S is a subset of follow S prime. So follow S is a subset of follow S prime. S prime. Okay, next one. S prime, it is the same. Follow E prime. Follow E prime. Okay. Then T prime. Follow T prime. And then F is a subset of V. Follow V. And here we have S is an element of E. Follow S is an element of E. Okay. And S prime S. S prime to S, so practically these are equivalent. Okay. And E, follow E is a subset of follow T. So we have E to T. That's why I started to draw this way, because we have to follow all these arcs. Okay. And then T is a subset of follow F. Okay, that's it. Okay, so we have these. I'm going to summarize it here. The picture. And we can determine the follow sets by this one. So follow S is equal to the set containing the dollar sign and the semicolon. Follow E, actually follow S prime is the same. Follow E is the same, but also containing the closing bracket. Okay, T is the same, but also containing plus and minus. Plus and minus. Follow T. Okay, E prime is the same as E. The T prime is the same as T. T prime. F is the same, but also containing the multiplication and division, and V is the same as F. Okay, where it is interesting to see where we have non-terminal to E rules, because for that cases, for all the follow symbols, we have to include the grammar rule. So let's see the set of rules where we have the E rules, and it is for S to E, E prime to E, T prime to E, and that's it. So we have to apply for the dollar sign, colon, and closing bracket this rule S to E prime. So dollar sign, semicolon, and closing bracket. Let's see. Dollar sign, semicolon, and the closing bracket. Okay. Oops, it is not the same. Sorry. Okay, let's see the other rules. We have E prime to E for dollar sign, semicolon, and closing bracket again. Okay. And we have 3 prime to E for follow T prime, which is the same including the plus and minus. So closing bracket, semicolon, dollar sign, plus and minus. Okay, let's see. So at this point, the parsing table is complete. And let's apply. And it is applied in a way that we include the input, like this one. We have the stack. Okay, it is also easier to done in a table. So we have the stack, the input, and the output. The input contains the series of symbols at the input and also a dollar sign at the end. The stack contains the initial symbol and the dollar sign. And in this case, we have to follow the instructions in the parsing table. And this is the derivations. So for the S and A in the input, we have this grammar rule S2 ES prime, which means that in the input it is substituted by an ES prime, and we still have the dollar sign at the end. Okay, for the E and E, so we have an E at the input and we have a E at the top of the stack. We have the derivation E to TE prime. So this is applied, which means that, oh, sorry, this is, it starts with an V, so we have to apply something for the V. For the V and A, we have V to A, Okay, B to A, which means this starts with an A. And in this case, we have at the top of the stack and at the input the same symbol, so both are eliminated. And what remains is equal to, and oops, and the same here. And in this case, we have the same symbol at the beginning again. So we're just going to eliminate it. And then we have E and 2 plus 3. Okay, for the E and the number, let's see, here we have E and the number. Then we have the grammar rule, E2 TE prime, which practically means that E is substituted by TE prime here, and the remaining part is just copied here. Okay, the input remains the same. For the T and the number, since we have T here and a number here, we have to see the table in the row of T and the column of the number. So here we have this T to FT prime, T to FT prime, and then we have FT prime at the beginning, and then E prime, S prime, and the dollar sign, and at the beginning of the input we have these. Okay, let's see what we have for the F and the number. It is F and number. So we substitute TF by the number, so we have here like these two. Oops. And this one here. So we have these twos both at the beginning of the input and top of the stack, so these are eliminated. And then we have T prime, E prime, S prime, dollar. And here we have a sequence started with a plus sign. Okay, for the T prime and plus, we have T prime to E. So practically this T prime is eliminated from here. And for the E prime and plus, let's see, E prime and plus, we have the grammar rule plus TE prime. And we have to have just to copy the remaining part from the stack. And then we have this one in the input, so we can eliminate the plus sign. And then we have te prime s prime dollar, and here we have a number, and for the t and the number, here we have t to ft prime again, which means that t is substituted by ft prime. Okay, for the f and the number we have, like here, f to number. So here we have like a number 3, sorry, and then we can eliminate the number 3. Okay, and what remains is e prime s prime dollar, and here we have a semicolon. Okay, for the t prime and the semicolon we have t prime to e, so practically it is eliminated. For the e prime and the semicolon we have the same. Okay, so it is e prime is eliminated as well. For the s prime and the semicolon, we have semicolon s prime. And the input starts with a colon. So we have to eliminate the semicolons from both here and here. Okay. So practically we have this S again and the print. Okay. For the S and print, we have print ES prime. So we have this at the beginning. And here we have print at the beginning and the same at the input. So it is eliminated. Then we have E in brackets and these, and then we can eliminate the opening bracket as well. Okay, and then we have just the E and A at the beginning of the input. So for the E and the letter we have TE prime. So start to derivate it in a way how we did with the numbers. So here we have TE prime at the beginning, and then closing bracket S S prime, S prime. Okay, somewhere I lost the dollar, sorry. We have the dollar sign here, dollar sign, dollar sign here, dollar sign here. Okay. So with the a minus 1 for the letter n t, we have ft prime, ft prime, for the f and the letter we have f to v, for v and a we have v to a, so here we have a, t prime, e prime, closing bracket, s prime, and so on. So we eliminate the e, and then we have t prime and t prime and the minus, and for the minus and t prime we have the t prime to e, so this is eliminated, and then we have e prime and minus. For the e prime and the minus we have minus t prime, and we have the minus at the beginning, so we have eliminate these minus signs. Okay, and then we have t and a number, and for t and the number we have ft prime, so f3 prime, f and a number, we have f and a number, so we have a number here. Actually it can be substituted by just a number, it is okay, so we have the number, it can be eliminated, and then we have just t prime e prime, closing bracket and dollar sign. So for the t and the closing bracket, t prime and closing bracket t prime to empty, So it is eliminated. And then E prime and closing bracket, E prime and closing bracket, E prime to empty. So it is eliminated again. Sorry. Then we have the closing bracket at the beginning. So both are eliminated. And for the S prime and dollar sign, S prime and dollar sign, we have S prime to E. So this is again. So finally we have two dollar signs and both are eliminated, and that's it. It's over. Okay, what I modify is probably just okay. So these numbers here can be okay, a variable, and okay, can be understood this way. So this is the derivation, and if we follow these steps, we can draw the parse tree. So let's see how a parse tree looks like. So, but in this case, so we have S as an initial symbol, and then V equal to SE prime. So we have S as an initial symbol, and then we have what we have on the right hand side is V equals to ES prime. V equals E and S prime. Okay. Oops. Okay, then the following is V to A. The next one is V to A. So we have an A here. E to A. Okay. E equals 2. And then the next step is E to TE prime. So we have T and E prime. just want to move. Okay, let's go further. T to Ft prime, F T prime, okay, then F to number, so here we have the 2, okay, and then T prime to E, and then plus TE prime for D prime, so plus T E prime, okay, T to Ft prime, okay, and then F to a number, so here we have the 3, okay, then T prime to empty, E prime to empty, okay, and then we have S prime to colon S prime, so here we have this S prime, and for this one we have semicolon and S and S prime, okay, and then for the S we have print E, so we have print, we have bracket E and the closing bracket, Okay, so print opening bracket E and the closing bracket. Okay, for the E we have TE prime. Okay, I will finish soon. Okay. So here we have E to TE prime. And then T to FT prime. F T prime. And then F to V and V to A. F to V and V to A. And then we have T prime to E. Okay. And T to FT prime. Yeah, E2 minus T prime. Okay. So minus T E prime and then T to FT prime. Oops. Okay, and then F to a number, which is in this case 1. And then T to E, E prime to E, S prime to E, S prime to E. Okay, T to E. And S prime to E. And that's it. Okay, I try to improve its arrangement a little bit. Okay, so if we read it, it likes A equals to, okay, 2 plus 3 semicolon print A minus 1. That's it. Okay, it looks good. S prime print E S prime. So this S prime is missing from the graph. Print E S prime here. Okay. This is the only thing missing. So here we have a S prime again. Okay, so this is the parsing table what we have at the end.